In this video, I will show you how to solve probability equations. Now, these are the models, the probability equations that we will solve. And the important thing is, how do you know which equation you're going to use? So, hopefully you understand that these symbols mean the probability of A given B. Alright, if you did not know that, then you need to watch some of my earlier videos in the playlist. But this means given. And this is the only formula that involves given. So, if the problem says anything about given, you're going to use this formula. Now, this formula involves the word and the word or. Now, the word and is not going to help us because this formula also involves the word and. This formula also involves the word and. All the formulas have and. But guess what? This formula has the word or in it. And yeah, this is the only formula that has or. So if you see the word or, and I hope you understand that another way of writing or is to use this symbol. This means A or B equals. Alright? Just like this symbol means A and B. So if you if you see or if you see this symbol, you'll know that you will be using this formula. If it doesn't say given and it doesn't say or, then you're probably going to use the middle formula. So, taking a look at problem number 1. Right away, I see the or symbol right there. That tells me that we're going to be using the addition rule, which says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So let's just write that down again. So it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, we know the probability of A is 0.25, so I'm going to put that in. We know the probability of B, 0.45. We know the probability of A or B. That's right here, 0.55. We're supposed to find the probability of A and B. We're supposed to find this. So I'm going to just leave this as the probability of A and B, and we will solve for this part of the equation. So we notice that we have some like terms right here on the same side of the equation. So we might as well combine those together. I will bring down the 0.55, but combining these two, that's going to be 0.7. And then I will bring down the minus probability of A and B. Now, to get the probability part by itself, I need to subtract this from both sides. So I'm going to subtract 0. You know what, I'm going to call it 0.70 because that's probably what you were thinking. So I'm going to subtract 0.70 from both sides. So this is going to give me negative 0.15. And then I will bring down this negative probability of A and B. To fix the fact that both of these are negative, technically we will divide both sides by -1. But of course the bottom line is that we will get the probability of A and B is equal to positive 0.15. And of course you could write that as 15% as well. So there's the final answer to problem number 1. Okay, let's take a look at problem number 2. That almost didn't fit. I think I'll try a smaller font. Alright, for problem number 2, these are the two expressions we are given, and this is the one that we are looking for. Speaking of given, I see the given symbol right here. Well, only one formula involves given, and that's this one. So I'm going to write down this formula, but instead of A's and B's, I'm going to use X's and Y's. So here goes the formula. I know that the probability of y given x is going to equal the probability of y and x. Alright, I'm looking at this formula. See, I have a and b, so I'm putting y and x over the probability of x. Okay, this is the given, right, in the denominator, and in the formula I notice that the given is in the denominator. Alright, so this is the formula. Now let's look back and see how much of that we have. So we are given the probability of x and the probability of x and y. We're given the numerator and the denominator, so let's write that down. So the probability of y given x will equal, okay, in the numerator we have y and x, so that's this 1/5. In the denominator I have the probability of x, that's 2/5. So it's a matter of 1/5 divided by 2/5. Now, you could cheat and do this in a calculator, but let's try it by hand first. So when you have a fraction divided by a fraction, or which is what we have, a fraction divided by another fraction, what you do is you multiply by the reciprocal. So I take the first fraction and I multiply by the reciprocal of the second fraction. When I say reciprocal, instead of 2/5, it would be 5/2. Okay, so this is going to be, so I have the probability of y given x, multiplying straight across, that's going to give me 5/10, which reduces down to 1/2, which is 0.5, which is 50%. Okay, so that is the answer in all of its forms. Now notice I could have put this expression in my calculator if my math skills were quite weak. Okay, I could do this. I could make a fraction, and then in the numerator I could put another fraction. So here I could put 1/5. Okay, now I could go to the denominator and make another fraction, and that would be 2/5. Okay, so can you see this is exactly what I have right here. So if I just hit enter, then it gives me 1/2, which is what I got. Alright, that was problem number 2. So now let's do problem number 3. Well, there's that given again. Alright, as soon as I see the given symbol, I know I'm going to be using this formula again. So here we go, C given B this time. Alright, I'm going to change colors. So, the probability of C given B is going to equal the probability of C and B divided by the probability of B. Okay, again, I'm just copying this formula, the pattern of it, but instead of A and B, I'm doing C and B. So basically I replaced the A's with C's. Okay, great. Now I'm just going to fill in everything I know. So I know the probability of C given B is 0.72. So that tells me that 0.72 is equal to, let's see, I also know the probability of C and B. That's the numerator, which is 0.36. What I don't know is the probability of B, so I'm just going to leave it as the probability of B, like that. I feel like I need a tiny bit more space in here, so I'm going to try to move this down a smidge. Okay, so I need to solve this equation. Now I have learned when the variable is in the denominator, an easy shortcut is that I can swap these. Alright, this comes up a lot. If I have a number equal to a fraction and the variable is in the denominator, the easiest thing to do is to swap these. Alright, so if I do, I'm going to get the probability. Why do I have the fat ink again? I need the fine ink. So that's going to be the probability of B is equal to 0.36 over 0.72. Alright, you just swap these. And so that gives me the probability of B by itself. So that means the probability of B is equal to, and I'm going to need to put this in my calculator. I have to slide this over to make space for my calculator. So I'm going to have 0.36 divided by 0.72. Okay, so that's 0.5, which of course is the same thing as 1/2, which is also the same thing as 50%. So there it is in all of its forms. Okay, that was problem number 3. Let's move on to problem number 4. Okay, I'm going to change ink. I see right here I've got the OR symbol. And there was only one formula that had the OR symbol in it. Well, or the word OR, and that's the addition rule. So this is the equation that we have to use. Alright, soak it in, soak it in. I'm just going to replace all the A's and B's with D's. Wait a minute. I feel like this is a mistake. Ha! I have D's and E's over here, but then I have A and B right here. Kabam! I changed it to D or E. So anyway, like I said, we're going to use the addition rule because it has the OR in it. So the rule goes like this. The probability of D or E is equal to the probability of D plus the probability of E minus the probability of D and E. Okay, now what parts of this do we know? Well, we're looking for the probability of D or E, so that's going to stay the same. So I'm just going to copy that down. The probability of D or E. We know that the probability of D is 45%. I'm going to go ahead and convert this to a decimal. You don't have to. Your calculator does have a percent sign on it. So if you wanted to, you could put 45 and then hit second. Whoops, I missed. Second. And so there's 45%. You could leave it like that and work with it. But a lot of students would forget the percent sign. They'd wind up adding 45 and 25, and that's just plain wrong. So it's safer to go ahead, instead of 45, write 0.45. Instead of 45%, that's the same as 0.45. probability of E, I'm going to put 0.25. And we also know the probability of D and E is 10%, so I'm going to put 0.1 or 0.10, so minus 0.10. So this is going to be a little bit extra easy because all of the numbers are on one side of the equation. So we'll just add them all up. So, okay, the probability of D or E should equal so 0.45 plus 0.25 minus 0.10. So that's 0.6. Which is the same thing as 60%. So that is the final answer to problem number 4. Okay, problem number 5. Again, I see the OR symbol right here. So that once again tells me that we're going to be using the addition rule because it's the only one that has OR in it. So soak this in. I'm going to be writing this equation, just substituting instead of A's and B's, I'm going to have M's and N's. So here I go. Let me change colors. So M, sorry, I'm putting parentheses in the wrong place. Let me try that again. The probability of M or N is going to equal the probability of M plus the probability of N minus the probability of M and N. Okay, now I'm just going to substitute in everything I know. So the probability of M is 22%. And again, I'm going to put 0.22 instead of that. Alright, so I have 0.22 right there. I know the probability of M or N is 88%. So that's right here in the front is 0.88 as a decimal. And finally, we know the probability of M and N is 12%. Okay, but that's over here at the end. So this is what we're looking for, so I'm going to leave that the way it is. And then minus the 12%, so 0.12. So I need to get this part by itself, the probability of N. But I notice that I have these like terms all on the same side of the equation. So I should combine those right now. So that's going to leave me 0.88. And I will still have the probability of N. But combining these like terms, if I do 0.22 minus 0.12, that should be 0.1. So I'm going to have plus 0.1, or you could call it 0.10 if you wanted to keep it 2 digits. And of course, now it is time to subtract 0.10 from both sides. So minus 0.10 minus 0.10 from both sides. So, of course, that is going to leave me with 0.78 is equal to the probability of N. And that is the final answer. We could also write this as 78% is equal to the probability of N. Easy peasy. Okay, it looks like we have just one more of these. So this will be the last problem on this video. Time to switch colors. This problem has the given symbol in it, J given K. And there's only one formula that involves the given, that's this one. So watch this very carefully. I'm just going to recopy this formula, but instead of A and B, I'm going to have J and K. So that formula is the probability of J given K is equal to the probability of J and K divided by the probability of K. Alright, the given is always the new total, and I've got target over total, so that reminds me that the given always goes in the denominator. Anyway, this is the formula. Let's fill in what we know. So we know the probability of J given K. We know this number on the left. So we can go ahead and write 0.125 equals. Alright, we know the probability of K. That's in the denominator. So 0.50. We are looking for the probability of J and K. So we're just going to leave that in the numerator. Okay, now we have to get the probability of J and K by itself. Some students get thrown because of the probability expression, but just remember, imagine that I had 7 is equal to x over 5. If I were trying to solve this little equation, what would I do? Almost all of you know that to get x by itself, you would multiply both sides of the equation by 5. That way the 5's would cancel each other out. So don't get distracted by the fact that it's all these parentheses and things. This whole numerator is just like an x. So just like I would multiply by 5 because it's in the denominator, for this equation I would get the numerator by itself by multiplying both sides by 0.50. So 0.50 on both sides, because that way these cancel each other out, leaving probability of J and K all alone. Now we can go ahead and multiply these together. Little calculator action. Okay, so 0.50 times 0.125. Okay, 0.0625. Okay, so I've got, well, I meant that to be blue. OCD, don't mind me. 0.0625. Is that what it was? I have no memory. Okay, and that equals the probability of J and K. So this is the final answer. If I move that decimal point twice, I can write it as a percentage. So this would be the same thing as 6.25% is equal to the probability of J and K. So that's great. I really kind of enjoy these problems. If you know the formulas, or if the formulas are given to you on a formula sheet, which I'm being nice enough to do for my students. Hopefully, if you're a random internet person, your teacher or professor will do the same. Okay, so that's it for problem number 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.